Hi all. Why don't we try another textbook or another set of textbook problems, but this time approaching it from the base point of view. So we are going to be using KB, the basicity constant, and it looks like they're still going to give us pH. No, we have to calculate pH, but instead of calculating the pH of an acidic solution, we're calculating the pH for a basic solution. In problem 2, they gave us caffeine, which acts as a base, and now they're asking us for the KB. So we are going to calculate pH from KB and vice versa. Let's take problem 1. Problem 1. So this is tricky in the sense that you know how to calculate pH. We need the concentration of H3O plus, okay? Uh, or since we're working from the base point of view, or if we could get POH, then we know the equation POH plus pH equals 14. Okay, and to get POH, we need concentration of OH minus. Okay, so there are a couple steps. When in doubt, I feel much better, and I think most students do when they see a chemical reaction. And then we could relate everything to that. The chemical reaction is, so they don't give us a base, but we could use a generic term B, and I'll go ahead and put in the phases. And a base, when you throw it into water, it grabs a proton. It accepts a proton. Therefore, when a neutral species grabs a H+, then you see that H, but also you gain a +1 charge, aqueous. When that base grabbed the proton off of water, water became the conjugate, that acid became the conjugate base, OH minus, aqueous. If we are able to get that concentration at equilibrium, we could get POH, and then if we get pH, we could get POH, we could get pH. We are setting up an ice table. Ooh, I think we're good. Yeah, I think we're good. So the initial concentration of the base is 0.25 molar. Water doesn't count in the equilibrium expression. We have no conjugate acid and conjugate base at the beginning. Minus x. Okay, we've done this before. 0.25 minus x, x and x. Taking a look at the KB, it's 10 to the minus 8, so we are going to try to use the extra small approximation. And just as a reminder, let's write out the KB expression using this compounds that we see here, BH plus times concentration of OH minus over the concentration of B. And I should have given you time to do this on your own. Do you want to finish the rest of it and ultimately get a pH? Okay. All right. I'll continue working on this. 6.8 times 10 to the minus 8 equals x squared over 0.25 minus x. Because Kb, the equilibrium constant for this base reaction, is very, very tiny, we're going to use the x is small approximation. In general, if your k is 10 to the minus 4 or smaller, try to do the x is small approximation, and then you will check whether it is valid. Cross out this minus x. I'll go ahead and solve for x directly. 6.8 times 10 to the negative 8 equals times 0.25, 0.25, and then I gotta take the square root. Okay, let's go to scientific notation. 1.304. 1.304 times 10 to the minus 4. That's a molarity, and that's the molarity of our conjugate acid. Oh, that's more importantly, that's our molarity for our hydroxide ion. If X is small, is valid. Let's do our check. 1.304 times 10 to the minus 4. We're specifically looking at this expression here. The equilibrium of base is 0.25 minus x. If x is super tiny, we could ignore it. And that's what we did here, but we just have to double check that it's tiny. It should be less than 5% of your initial concentration. So you divide by the initial concentration times 100% equals, divided by 0.25 times 100. Let's get this out of scientific notation so we could literally see that it is 0.052 and it's already a percent because I multiplied by 100%. That is definitely less than 5%, and therefore I'm going to say valid. Okay, awesome. I think we're almost there. The pOH equals negative log of 1.304 times 10 to the minus 4. I am working kind of fast because this is the easier of the two problems, and I'm a little worried that the second problem might take a long time. So you're always free to rewind and pause. What am I doing? 1.304 times 10 to the minus 4 equals log of that equals times negative 1 equals my pOH equals 3.88. Okay, this is a basic solution, so the pH should be above 7 when you're at 25 degrees C, because at 25 degrees C, neutral pH is 7. So pH equals 14 minus that number. 14 minus that answer, 10.12. Good. The pH indicates an basic solution. Basic solution. And again, nothing to fear. You just have to walk your way closer and closer to pH through the concentration of OH minus. Now, the problem that I am a little worried about, but we're going to try it. I haven't worked this through yet. I'm doing this from scratch, and you're going to see my thinking. Well, we have a pH. Okay, that's a good start. And from the pH, we could definitely get pOH. And from pOH, we could definitely get OH minus, which is good because we have a molecule that's basic. We're not going to draw out the structure when we look at the chemical equation. Why don't we do this? C8H10N4O2 plus water. Okay. What does a base do? It accepts a proton, or I like to think of it as grabbing a proton off of the acid. And you could do that by just putting the proton in the middle, no, the proton at the beginning. So the letter H, hydrogen, C8H10N4O2. Now the thing is, you remember when you grab a proton, you're increasing your charge by +1. We started out as neutral, so this is definitely plus. And then when that water loses its proton, it becomes minus. Another trick is you have net neutral reactants. You should have net neutral products, so the plus cancels out the minus, net neutral. Well, let me go ahead and set up the ICE table and let's evaluate, do we have enough information to get KB? You know what? Why don't I should have focused on this at first. We know that KB is what? KB equals, in general terms, the BH plus concentration times the OH minus concentration over the concentration of B. We did that in the previous problem, right there. Okay, well, 0.15. I'm sure a lot of people out there are seeing exactly what to do. I'm almost with you. So normally, when you set up an ICE table, you're solving for the equilibrium concentration of one or all of the components. But the thing is, we know the equilibrium concentration of OH already, because we could get it from the pH. So let me do that first. Let's get something that we know for sure. So the pH equals 8.45. We know that 10 to the minus pH equals, no. I mean, it does, but let's not go that direction. I don't want this. I want the concentration of OH minus at equilibrium. So instead, let's do POH. 14 minus 8.45, 5.55. If you know where I'm headed towards and you think you can do the rest of the calculations, go ahead and pause the video and try it. I will catch up. 10 to the minus POH equals 10 to the minus 5.55 equals. In my calculator, I could do this two different ways. I could do 10 with the caret, negative 5.55. That should give me an answer. Okay. Or, I think people call this the inverse of log, negative 5.55, and I get the same answer. Let me get that into scientific notation. I got 2.8. Let's give us a couple more digits than usual. Times 10 to the minus 6 molarity equals the concentration of OH minus. Did we lose track of why we need that? We need this because that is equilibrium concentration of OH minus. That number goes right there. 2.8184 times 10 to the minus 6. Why is that useful? Because I know the change now. This was plus 2.8184 times 10 to the minus 6. If I gain one molecule of OH minus, I gain one molecule of the conjugate acid, plus 2.8184 times 10 to the minus 6. And this is 2.8184 times 10 to the minus 6. I'm going to keep this number in my calculator, and I'm hoping I can figure out the KB just by typing an answer. Well, we have this minus 2.8184 times 10 to the minus 6. So you do have the minus x plus x plus x change, but now we literally know what x is. And this one is 0.15 minus 2.8184 times 10 to the minus 6. It's very tiny, but we don't have an x to solve, so we're not doing the x is small approximation. There's no need to. We know what x is. Now, we know that kb, which is what we want to look for, has this expression. How can I do that without losing this number? It's really x squared minus 0.15 minus x, or answer squared. So I hope this works. Answer squared divided by 0.15 minus answer, and that should be this expression. I just want to make sure I'm not doing anything wrong. Right now, I have the KB equals, and again, all I did was plug in the numbers in the E row up in this KB expression. I got 5.30 times 10 to the minus 11 circle. Now, I do have the answer from the solution manual. I just hadn't worked it out myself, and it's correct. 5.3 times 10 to the minus 11. Do you want me to zoom out? Okay, nice problem, because we had to take a couple steps from this piece of information to realize that we really want that piece of information.